Okay, continuing on in Unit 1, we're going to discuss density. And density is something that relates mass to volume. So the definition of density is mass divided by volume. So we learned that mass is the amount of matter an object contains. So, and it's regardless of the gravitational pull. So typical units for mass that we see are in grams. So mass has units of grams, whereas volume, we see units of liters, milliliters, cubic centimeters. The units of volume that are typically used with density are milliliters or cubic centimeters. So units that you'll see for density are grams per milliliter. You can see it written like that, or grams milliliter to the -1, or grams over milliliters. So the units grams per milliliter are typically used for liquids because you use a graduated cylinder to measure out your volume in milliliters, which we'll see a graduated cylinder in lab. Other units for density are grams per cubic centimeter. So this is we typically see with solids. So for instance, when we measure the density of a block of wood in lab, the units will be grams per cubic centimeter. Now, I'll cover that in just a second. I was thinking I'd show you a trick, but I'll wait till we start solving problems. So here are typical densities. Water has a density of 1 gram per milliliter, whereas ice has a density of 0.916. So ice floats. Why? Because it has a lower density than water. So this is very important, the fact that ice floats on water. Think about ponds and lakes, that the ice floats in the wintertime so that things are able to live underneath. So you can go fishing, ice fishing. But it's if ice were more dense than water, there would be a problem. So, like I said, water has a density of 1 gram per milliliter. Ice has a density 0.916. Body fat 0.918. So if you think about swimming or hot tubs or body fat would float, but we're not 100% body fat. One of my friends was looking for a hot tub, and so she was hot tub shopping, and I thought, I'll go along with her. So we go to this hot tub dealership, and this guy's really trying to sell her on this one hot tub. And he said that this one hot tub was better for women because women are more buoyant. And it kind of looked at him, and I thought, what he's really saying is that women have a higher body fat percentage. So the way the seats are designed in this hot tub are more accommodating to that fact. So, it's just a way to sell something, but buoyant. So he was really addressing the body fat of women. Alcohol has a density less than water. So a lot of alcohol mixes with water, so you can't see the different layers. But if you've ever had a drink that has different layers, it's due to the densities, different densities of the alcohols, and they don't mix. I do recommend staying away from those drinks because your stomach tends to not like that when things don't mix. One of my friends liked B52 shots, and so I took a B52 shot, and that's all I had to drink that night, and I was so sick. And it has different layers, different densities, alcohols, and yeah, just not very soothing to the stomach. It turns out if you ingest a lot of gasoline, which has a density less than water, and the way if you're taken to the hospital, you've ingested a lot of gasoline, the way they treat this gasoline poisoning is by giving you milk. And it turns out that milk and gasoline don't mix, so it creates this two-layer system, and then you are inclined to vomit. So, if you think about that, and then you think about these drinks that are two layers, and like you're kind of doing that to yourself, you might want to stay away from it. Not good for me. Some people can handle it, but not for me. So, all right, back to chemistry. Now, when we're in lab and you're measuring out liquids, for instance, it's very useful to use density. So let's say you wanted to measure out 1.5 grams of ethanol, but ethanol is a liquid. So you don't have a scale, so you can't use a scale, but you could use a graduated cylinder. And a graduated cylinder measures volume. So let's see, if I want to measure out 1.5 grams of ethanol, which has a density of 0.789 grams per milliliter, I would be able to figure out what volume is required. So we know two variables, we need to solve for the third. So there are two ways to set this up. I'm going to go through the first way. It's just like a conversion problem. Now, think of density as a conversion factor. But it's not an exact number because it is measured. So this is, oops, I just erased that. It's a measured number. So you need to count those sig figs. Okay, so how many milliliters of ethanol are there in 1.5 grams? So 1.5 grams is our starting quantity. So 1.50 grams of ethanol over 1. And I'm going to use the density, and I need grams to cancel out, so I'm going to put the density on the bottom. So grams canceled out. Enter this into your calculator. So 1.5 divided by 0.789 gives you 1.901140068 milliliters. Okay. So this number has 3 sig figs. This number has 3 sig figs. Since it was division, my answer can't have more sig figs than either of the original numbers. So we're going to have 3 sig figs in our answer, and this is our answer. Don't forget to put the units. So that's one way to solve this density problem. The other way, I'm going to show in the top of page 16, is using the triangle method, and perhaps some of you have seen this. I caution you when using this method. If you don't fill in the triangle correctly, you're going to get all your answers wrong. So it might be better for you to use the conversion factor method. But I just want to, teach different ways because I know everybody has a different learning style. So remember that density is mass over volume. So when you fill out this triangle, it goes D, M, V. And where do you go to get your driver's license? The DMV. So if that helps you remember it, great. Now the way this triangle works is you cover up whatever you're trying to solve for. So how many milliliters of ethanol? We are trying to solve for a volume. So you're going to cover up volume. So I'm just going to put an X of it. Imagine putting your finger over it. You just can't see my finger now. So you're going to cover up volume. And then write that volume equals M over D, mass over density. So if they were, since they're above and below, it's divide. If they were to the left and right of each other, it would be multiplied. So volume equals mass over density. So in order to solve for volume with this problem, we're going to plug in the mass, so 1.50 grams, and then you're going to plug in the density, 0.789 grams per milliliter. Now with this method, it's not as easy to see how the units cancel out, because when you divide by a fraction, it's the same as multiplying by the reciprocal. So you divide by a fraction, which is what we're doing right here. It's the same as multiplying by the reciprocal. I know I just repeated myself. I just want to say that again. So it's the same as multiplying by the reciprocal. So I'm going to cross this out and multiply by the reciprocal. The reciprocal is just the flip. So there, you see your units cancel out. And then our units are in milliliters, and we'll end up with the same answer that we got above, 1.9 milliliters, because you did the same exact operation. So either way that you find easier, go for it. Using this density triangle, you can also, if you're asked to solve for density, D is M over V. If you're asked to solve for mass, mass is D times V. So a lot of students find that density triangle helpful. I will caution you, just make sure that you have the triangle filled in correctly. I've had students miss a lot of points because they had the wrong triangle. So make sure you think, where do I go to get my driver's license? The DMV. So, all right, there's some practice problems here on page 16. I want you to hit pause and work these problems. Okay, so the first one just asks you for density, and so it's not really a conversion problem. It's just putting mass over volume. So it's not really a conversion factor like we'd seen with the first example that I did. So you just have to think, what is the definition of density? It's mass over volume, and then you have to plug in the mass and plug in the volume, and then adjust for the sig figs. This has 3 sig figs. This has 3 sig figs. So your answer cannot have more than 3 sig figs. So that's how we came up with 0.798. And then the units are grams per milliliter. So you need to make sure you put the units on this. All right, and number 2, it's a pretty straightforward conversion because you're given the volume and then you're given the density. Now you can work it either way. I worked it as a conversion problem, so 18 milliliters is your starting quantity, and then in order to get milliliters to cancel out, I need to multiply by the density. So I have 3 sig figs here, 2 sig figs here, 2, and my answer. Now this last problem, be careful with. Okay, so the question milk has a density of 1.03 grams per milliliter. How many milliliters are in 25 milligrams of milk? I want to point out this. Here I have grams in my density, and then I have milligrams in my mass. So I'm going to need to convert somehow. So let's just work this through as a conversion factor problem. So this is my starting quantity, 25 milligrams over 1. In order to use my density, if I tried to use my density now, my milliliters wouldn't cancel out. I mean, my milligrams wouldn't cancel out, so the milli would still be there. So we need to convert milligrams to grams. So milligrams to grams. So in 1 gram, there are 1,000 milligrams. So milligrams cancels out that way. Now that I'm in units of grams, I can use the density. So I'm going to divide by the density. And I get this. So if you had tried to use the density triangle, that doesn't account for the differences in units. So that's where you have to be really careful. So 25 divided by 1,000 divided by 1.03 gives us 0.02427 milliliters. How many sig figs can I have? I have 2 here, 2 here, so I can only have 2 in my answer. These zeros are placeholders, so right there. So my answer is 0.024 milliliters. And that is density. Alright, moving on, we're going to talk about specific gravity. So specific gravity is the density of a substance divided by the density of water at the same temperature. So, specific gravity. Density of substance divided by density of water. So we know the density at 25 degrees Celsius, or room temperature, of water is 1.0. And let's say our substance is an alcohol and it has 0.78 grams per milliliter as the density. So grams per milliliter over grams per milliliter, the units cancel out, and there are no units. So no units on density. So why is specific gravity useful then? Well, it turns out there's a piece of equipment that we'll see in lab that's called a hydrometer, and they're very useful because they can be used to determine the relative density of items. So in medicine, the specific gravity of someone's urine can be measured, and if it's off, it can be an indication of an illness. It also can be used in winemaking. Now, in winemaking, specific gravity can give you an idea. Specific gravity of the wine can give you an idea of how much longer the grapes need to ferment. For instance, grape juice is 20% sugar, dissolved sugar. The specific gravity of grape juice is 1.082. And remember that specific gravity has no units. Whereas dry wine, which is 12% alcohol, and remember that alcohol has a density less than water. So the more alcohol you have, the lower your density will be. So dry wine has a density of 0.984. So a hydrometer can be used to measure specific gravity, and you just have to submerge it in that liquid, and you can know pretty quickly whether you need to let your grapes ferment a little bit longer or they're done. So let's work a problem that involves specific gravity. So the specific gravity of chloroform is 1.4832. What is the mass of 5.6 milliliters of chloroform? So they give us a volume and they want to know the mass. And remember that units on mass are grams. So you can convert specific gravity to density very easily. And the way you do that is just by putting units on it. So you know that specific gravity is unitless. To make it into density, you're just going to add units of grams per milliliter. It's kind of like you're dividing by 1 gram per milliliter. So for this problem, I'm just going to work it as a conversion problem. Set it up. Our volume is our starting quantity, 5.6 milliliters over 1. And then I'm going to use this density as my conversion factor. And then I'll get to grams. So I need milliliters to cancel out. So I'm going to put the density in this orientation. Now I think I've maybe made mention of this in the past, but I want to make sure it's clear. The 1.4832 goes with the grams. They are married. They stay together. They don't get divorced and get remarried. They stay together. So 1.4832 goes with grams. Milliliters doesn't have a number associated with it. So 1.4832 grams over 1 milliliter. So you multiply 5.6 times 1.4832 and you end up with 8.3 grams of chloroform. So let's check our sig figs. 2 sig figs here, and I have 1, 2, 3, 4, 5 sig figs here. So I should end up with 2 sig figs in my answer. Okay, so anytime you see a problem that involves specific gravity and you're asked to solve for either mass or volume, add those units to specific gravity. Okay, so that concludes the lecture on density and specific gravity. There are practice problems that you need to do, or there are homework problems as always, and then there are practice problems in the pink book. There are also some practice problems in the pre-lab, so work on those. I'll tell you a density story that this was quite a while ago, but my husband and I went to the gas station to get gas. So I was driving and he pumped the gas and got back in the car, started the car, and our car was less than a year old at that point. So we hadn't had any problems with it. So I start the car and it stalls out. It was an automatic, never had done that before. I try and start it again and it stalls out. So we thought it was kind of weird. It was about 7 o'clock at night. That's Ethan, our son. He'll be contributing a lot to these lectures. I'm sure you've already heard him. But, okay, so it was about 7 o'clock at night. I tried to start it one more time and it stalled out. And fortunately, we were close to home. So we just pushed the car into a parking spot, walked home. And the next morning, I called AAA. So AAA met me at the gas station, and because I had to go teach, and he tried to jump it, nothing, so towed it to the dealership. So they dropped the car off the dealership. Then I went to work, and I got a call from the dealership a few hours later. They said, "Ma'am, your car does not run on water." And I said, "Huh, I didn't know that." I mean, it was real smart ass that was talking on the phone with me, so kind of frustrating. So what had happened, the gas lines were filled with water. So instead of pumping gas, water had been pumped into our car. So, the mechanic who was on the phone was saying, "You might want to call the gas station where you purchased this water and find out what's going on, because they need to refund you, and they also need to pay for this $350 worth of damage that's, has occurred." So I called the gas station, and the gas station said, "Oh, no, that there's no way that happened. That we haven't had any other complaints about this. This is unreasonable. I don't believe it." So then, I'm thinking, oh my gosh, this is just so crazy, because, it was from the pump. So then I start thinking about it, I'm going to call the dealership back and see if they can save a sample of this gas. And so I call them back, and they were able to save a sample of the gas for me. And when I went to pick up our car, they put it in a Dasani water bottle, one of the small water bottles, and it was like this gross brown water, and then the very top of it was like this clear yellow substance. So the clear yellow substance at the top was gasoline, because gasoline is less dense than water. The brown murky substance was the water that could not fuel our car. So, it's very clear as to why our car stalled out, because you can't, your car can run on a certain percentage of water, but not like 95% water. So, on my way home from work, I stopped by the gas station, and I showed them this water that was pulled out of our car. And he said, "Huh, okay, I see that, this is possible. In fact, we've had quite a few other complaints, and the damage that was done to your car was far less expensive than other cars, because they actually ran for a longer period of time, so more water got into the engine." And so he ended up refunding the gas and all the work that was required on our car. And I guess the way the water got into this was, a big rainstorm the night before we'd gotten gas, and they had tanks that weren't completely sealed, so water had a tendency to get in there. Water had a tendency to get into these tanks, and what normally is supposed to happen if you have a pump that is operating correctly is there are filters that can detect water, and when there's too much water, it will stop pumping gas. And these filters weren't operating properly, in addition to the tanks that got water in them, which is kind of disturbing from an environmental perspective. But at any rate, it was an interesting lesson in density, because I could clearly see there were two layers, and that the gas was the smaller layer, probably less than 5% gas, and the rest was water. So, a lot of students have asked me where that gas station was when I tell the story. It was an extension food mart. I think it's like kind of a shell station on the way to KU Med Center on Rainbow Boulevard, but I'm sure they've gotten things cleaned up by now, I hope. Anyways, I want you to work on your homework problems for density and specific gravity. Practice, 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 and be careful if you use that density triangle. All right, I'll see you next time.